All right, over here on the a granite surface plate, and I think any one of you who have done any machining knows what a sine bar is. This is a piece of steel that has centers on it, and this is exactly 5 inches from this center to this center, so it's a 5-inch sine bar. And we can tip it up. And if you remember trigonometry, then the angle, which is formed under a right triangle, so here we're going to call this, let's call this a right triangle, all right? And so here is the hypotenuse, and then here is the x, and this is the y. And so the sine of this angle is well, here I have it written here, okay? So the block here, so the y distance is equal to the hypotenuse times the sine of the angle. Or in other terms, the sine of the angle is y divided by the hypotenuse, right? And so if you want to set a particular angle, you would figure out which angle you want to set and take the sine of that angle and then multiply it by 5, and it would tell you what size block to have. So I don't have well, we can do that. Let's say we want to set a 10-degree angle. So we would take the sine of 10 degrees and multiply that by 5. So we would need a 0.8682. So about yay big. Now it would be a 10-degree angle. And here I have a, this is a 0.2, so if I had a 0.2, it would cause a very, very shallow angle. So we can use this formula again. We could say that we have 0.2, and we have a 5-degree angle, a 5-inch hypotenuse, and we'll take the arc sine of that. And so this is a 2.2924 angle. So that's how sine bars work. And what this video is going to be about is sine bars and slide rules. And what do they have in common? They actually have a common ancestor. So both of these items are predated by an instrument that was used quite extensively back in the 1700s, and you just don't see them anymore, and most people don't know what they are. So the idea of sine bars are this right triangle. The idea of slide rules, this is a nice post slide rule. This is a bamboo slide rule, so it's quite a nice one. The idea behind slide rules is the logarithmic scale. So because there's two numbers that are both logarithms, and you are actually linearly adding them in distance, if you add two logarithms, that's the same as multiplying. So you can actually use a slide rule to multiply two numbers. So you set one number, let's say, on the number 2, and then you go over here to 3, so 2 times 3 is 6. So if you haven't used the slide rule before, they're kind of fun devices. They also have other scales on them. They have sine and tangent scales, so you can get those off of here. There's log scales, all kinds of scales on this one. But basically the idea here is that they are logarithms. So what would some logarithmic scale and sine bars actually have in common? So let me go get that, and I'll show you that they're actually related. All right, it's inside this case here. It's an interesting case. It's made of shark skin, so it's really, really heavy duty shark skin case. I believe that's also called shagreen. S-H-A-G-R-E-E-N, shagreen. and it's very, very tough material. And this is a pocket set, so this was meant to be carried around. There's a little button here, latches it open, and then it flips open. And inside is a drafting set, or an antique drawing instrument set. There are things like an ink pen, very nice turned brass. Zoom in a little bit. Turned brass piece, and you put a drop of ink between the blades here. And, if you've never done that before, it's fun. It's a bit tricky. So it came with different things inside of it. Came with some nice dividers. The dividers are quite clever. They're half brass, half steel, and they're actually just made to swage together, or I guess soldered together or brazed together. I guess brazed together is the right word. I don't know exactly how they did that, but it's quite interesting. So the complex mechanism, they went ahead and did in brass, so that was easy for them to do the box pivot over here, and have steel points here where that's a wearing point. So that's kind of cool. My set is missing some pieces. There was also a thing looked just like this. It was a little bit bigger, but it was a compass, so it had one fixed point, and then it had one leg that you could replace, and you could put different things in that second leg. My set is missing that. It does have some of the legs. This is one of the legs that would have gone in, and this one holds a pencil lead, and it has a little pivot joint here. So that's kind of cool. And the other thing that I have in my set is, now I can't remember the name of it. There's an actual name for these little wheels, and what they're used for. Seamstresses use these. They'll use like a piece of like carbon paper, and then they can use a little wheel, and it makes marks on the cloth. I don't know what draftsmen used for these, but they were for making circles. The little pivot is still here, and so you could draw circles with this little wheel. And then the other thing that came inside the box was a rule. And these sets, you can find them on eBay still. These date to the 1700s, and they do go for quite a bit of money. If you have a complete set, you might pay $300 to $600, maybe something like that, depending on the set, depending how nice it is. This one has wood rules. Some of the really fancy versions of this had bone or ivory rules, but you can still find them. They were a coveted thing. They were small enough and coveted enough that people kept them. They didn't throw them away. They kind of squirreled them away, and so they kind of survived through the ages, and so you can still find some of these. This is like a draftsman or an architect's rule, so different scales. So draftsmen these days have like a triangular rule that has different scales on them, depending on which side of the triangle you're using. This one has 40 per inch, 35, 30 per inch, 25, 20, and 15 per inch scale. And on this side there are inches, and then there are these large 20, 30, I don't know exactly what those are, but and I don't know anything about this rule down here, but I think this is boxwood, and there's a cool little thing along the edge here that's braces, so you can trace the braces there. I think you can see that. But the thing that this video is about is this thing. Now, some of these drafting sets wouldn't have this particular piece. They might have parallel rulers, or they might have some type of other device depending on who this was going to. If it was going to a navigator or an architect or an engineer, they might have different instruments, but they all had basically the same brass instruments. They just had different rulers and things like that. Okay, so this thing here is what's called a sector. And sectors dated again somewhere between the late 1600s into the late 1700s, and then they disappeared off the face of the earth. Nobody had them anymore. So they're kind of a rare beast. Once again, you can get these in wood like this one is, or you can get them in bone or ivory, depending on which set that you had purchased. And there are lots of scales on this actual sector, and we'll start with some scales. So it's a 12-inch, about 12 inches long, folded 6 inches. It has some locating pins, so when you close it, it stays put. And we're going to start with some scales down here, and these lines are very, very fine. I don't know how this was actually manufactured, but these are very, very fine lines and very tiny little numbers. They must have had better eyesight back then than I do. But I'll go ahead and put on a macro lens and we'll zoom in on those scales. Alright, so I think you can see these three scales here. They're labeled N, S, and T. And if you pick up a slide rule, you will see N, S, and T scales on a slide rule. And N stands for natural logarithm, so that's just a standard scale. Like on a slide rule, maybe just like the A and the B scale or something like that. That would be like an N scale. S is the actual sine, so these are sines of angles, and T is tangents, so these are tangents of angles. And so let's go ahead and look at the sine angle. Let's see here if I can change my, there we go. So here's 40, here's 50, here's 40, 2, 4, 6, 8, yeah, so 45 is right here. So if we drop, for 45 degrees, if we drop down to this scale, here's 0.7, and so we're a little bit over 0.7. And we know that the sine of 45 is 0.707, so that looks good to me. And here's 30 degrees, so the sine of 30 degrees comes down here to 0.5, so that makes sense. And then if we go up to the top one here, the tangent of 30 is something like 0.5, almost 0.6. So you could check that out. But these are the logarithmic scales and the associated sine and tangent scales with respect to the natural logarithm scale. Now the natural logarithm scale back in this day was called a Gunter scale, G-U-N-T-E-R, Gunter. I don't remember Gunter's first name. Gunter was a mathematician out of England, and he's the guy who invented this scale. So before this, there was no logarithmic scales, and Gunter said, hey, we can have logarithmic scales. So a lot of times people would have rulers. They were generally 2 feet long, and they were called a Gunter scale. And they were basically just a logarithmic scale on a 2-inch rule, and they were used for operations, and I'll show you how you do that. Obviously, this is not a slide rule, and so how would you use such a thing? So let me change lenses again, and I'll show you how you use this thing. All right. So I know you can't see the scale, but you'll have to imagine that I can see the scale. And so this is the Gunter scale, so it goes way over to here. And so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's the first logarithmic interval. So let's say that I actually want to multiply two numbers. Let's say 2 times 3 like we did on the slide rule over there. I would set the first number. I'm going to use these dividers to set my first number, so I have it set to the number 2. And if I place one of the points here on 3, I can come over and I can read 6. So instead of having a second scale that slid back and forth, you would use your dividers to do that operation. And so this predates the slide rule, so this is the predecessor to the slide rule, and this is how you would use it with the Gunter scale. Now obviously we're not using the pivot function of the sector, and in fact sector sort of means certain things in mathematics, parts of circles and angles and things like that. And so how do we use the bendy part of this thing? Okay, so there are other scales. There are scales along this axis here, and they are marked S, T, and T. S, T, and T. And there's some other ones here, L, S, and C. I only know how to use one scale. There's an actual book. If you're really interested in these things, there's a book that Gunter wrote. I don't remember Gunter's last name, but if you search Google on Gunter and Sector, there's a 600-page book all about sectors. 600 pages. It's written in Old English, and so it's a bit difficult to read because it uses the Old English character set and language. So a little bit difficult to get through, but it is a 600-page treatise on sectors. Quite amazing. Okay, so let's go ahead and look at the S scale. All right. So the S scale goes 10, 20. Let me close this down. 10, 20, 30, 40, 50, 60, 70, 80, 90. Okay, so it goes from 0 to 90. And the origin of the sine scale is the pivot point of the sector, and there's actually a little divot, a little center punch prick right at the center where this thing bends, so you can put your dividers right in that little hole. And then I'm going to come out here to 20 degrees. So I'm measuring 20. All right. And now we have a line here at the end and a line here at the end. And if I put my dividers on this line, and now I have it set. So once again we have a right triangle. We have a known distance which goes along the S scale, and we have a known distance here in Y. So this is exactly our sine bar. We have a hypotenuse and we have a y distance. And so this S scale is basically the pre-calculation of the sine for this particular device. So right now what we've done is we've taken the number 20 and we've put it here in the Y. So this is now set to exactly 20 degrees. So you could set this to any angle you want, or you could actually measure angles. You could set this to some angle that you want to measure, and then take this Y distance and go over and read it right off of the S scale, and it would give you what angle that you had this thing set to. There's one other scale that I sort of know how to use, but I'm not going to really show it here, but I'll just describe it. There's a scale called POL, and imagine you have a circle and you want to divide that circle up into equal parts, kind of like a bolt circle. Maybe you're on a milling machine, you want to do a bolt circle. So you might want to have six go around, but you could have any other distance. And so the way that this works is that you have this known distance here from the center to the out, and that's your radius of your circle. So you just draw a circle that big, right? And then this POL once again goes from the center here, and we're going to come out here to the number 7, okay? And so now I have it set to the number 7. So what does that mean? Well, it means that 7 of these will go around the circumference of that circle. So you just take that start at one point of that circle, and you can just divide off seven segments. So you can divide the circle up into any number of segments you want by using this POL scale. So that's pretty cool. The scale has inches along here. It has that weird scale on the edge that's the 10, 20, 30, 40 scale that's not inches. It's larger than inches. I really don't know what that is, but like I said, it's got the Gunter scale, it's got the sine tangents, and it's got you can use this thing to do a lot of different measurements. That 600-page book tells you how to do lots of different stuff with a sector. But sector from the 1700s, predecessor to both the slide rule and the sine plate.